Today we're going to talk about the angles in a triangle. Now some of this will be review, but we do have a new theorem that I need to introduce. So we're going to start off with something that every student should know. The sum of the three angle measures of any triangle is 180 degrees. It doesn't matter what kind of triangle you have, the interior angles of a triangle will always add to 180. Now the new piece of information is something called the exterior angle theorem. And it says this: in any triangle, the measure of the exterior angle is equal to the sum of the measures of the remote interior angles. And I'm going to show you what that is. Remote interior. These are sometimes just called remote angles. So here's what we have. Here's an exterior angle. If I draw a triangle, I'm going to extend one of the sides so it has a tail to it. And this is considered an exterior angle, angle A. And angle A, if I have angle B and angle C, I'm not going to label this angle here. This angle is a linear pair to A, but he's not involved. Angle A is equal to angle B plus angle C. And there is a way to prove that, which we might do in class, or you could look it up. If A and this angle add to 180, as well as this angle and B and C add to 180. So they have that 180 in common, and they have this angle in common. So if you set them equal to each other, this angle would subtract away, and you end up with A is equal to B plus C. That might be a good little thing for you guys to justify on your own. A is equal to B plus C. And that is the exterior angle theorem. The sum of the exterior angle is equal to the sum of the two remote interior angles. But our reason can be the exterior angle theorem. Okay, so we're going to be using that in class. The second property here, or the third property I guess, is the fact that base angles of an isosceles triangle are equal in measure. That's something that you guys should also already know. So an isosceles triangle, if I have two congruent sides, the base angles are the two that are opposite the congruent sides. So those angles are equal in measure. And then another thing we should know is that each angle of an equilateral triangle, equilateral means all three sides are equal. Each angle of an equilateral triangle has a measure of 60 degrees, because when you think about it, if all three sides are equal, that means all three angles are equal. And 180 divided by 3 is always 60 degrees. We want to properly define an isosceles triangle. An isosceles triangle is a triangle with at least two sides of equal length. So that at least means an equilateral can also be considered isosceles. So an equilateral triangle is a subset of isosceles triangles. It's a special case. So at least two sides of equal length. We don't define isosceles by their angles, so that's an extra step. Two sides of equal length is what we do. And then the angles of a triangle. Every triangle determines three angles. If I start with ABC, the angles are BAC, ABC, and ACB. And those are called the angles of triangle ABC. That's kind of obvious. A and B and C. BAC would be the angle where A is the vertex. So you do have to remember that. The vertex is the center letter. ABC would have the vertex at B, and ACB would have the vertex at C. The interior of a triangle. The interior of a triangle, again, is pretty much self-explanatory. A point lies in the interior of a triangle if it lies in the interior of each of the three angles. So if you have a triangle, A, B, C, then the point on the interior would be in between A, B, and C, because it lies within all three angles. The exterior angle of a triangle, here's the formal definition: let ABC be an interior angle of a triangle, or angle ABC, and D be a point on AB such that B is between A and D. So let me draw that. D is a point on AB such that B is between A and D, and there's C up there. Then CBD is the exterior angle, so that angle there of triangle ABC. So we're going to find some measures using those true statements up above or on the previous page. We're going to find the measures of angle A and B in the figure to the right. And we want to look at the sum of the angles in a triangle and the exterior angle theorem to help us out. So if you look at angle A is the third angle in this triangle here. So angle A can be found by directly subtracting the other two angles plus 180, because we know the sum of the angles in the triangle add to 180. So you have to justify, you have to say the sum of angles in a triangle add to 180. We have to justify our steps. Solving that, we would get A is equal to 53 degrees. When you subtract 58 and 69 from 180, you get A is 53 degrees. So once you have that, then I can use the exterior angle theorem, because I have this triangle. This triangle has an exterior angle to it. So I can say 93 is equal to B plus A, because the exterior angle is equal to the sum of the two remote interior angles. So the exterior angle, that's not the exterior, 93 is equal to B plus 53. That's the exterior angle theorem. And then you end up with B is 40. So we always have to justify our steps when we work our geometry problems at this point. Now we're going to jump and tackle this beast, because it incorporates several things. We want to find the value of x in the measure of angle C, because we won't be able to find the measure of angle C without finding the value of x. So looking at this problem, we have an angle of 42 degrees. We have an x plus 12, which is this angle. This is not an exterior angle, by the way, because of this extra line here. The entire thing would be an exterior angle, but this by itself is not. And then we have two angles in here, and angle C. So if I can find the value of x, I can find the value of C, because the sum of the angles in a triangle will add to 180. So now I have to work on finding the value of x. Well, I have 42, and I have these markings here. So this triangle is isosceles. Because it's isosceles, that means that the angle up there is also 42, because the base angles in an isosceles triangle are equal in measure. Once I have that, the sum of the angles of this triangle will add to 180. So that's going to allow me to find a numerical value for that angle in blue, which means, well, I don't want to call that x, so let's call that y. Y plus 42 is equal to 180. So y ends up being, let's see here, subtract 42 twice from 180, y is going to be 96. So I'm just going to label that 96 degrees. Now what I can do, and this is kind of a doozy of a problem, but it's good to challenge you a little bit, is I can take the 96 and add it to the x plus 2, and that is an exterior angle. That's going to be equal to the sum of those two. And that's the only way I can solve for x, because I have one equation and one unknown. So the exterior angle is going to be x plus 12 plus the 96, and that's equal to 2x plus 9 plus 3x minus 1. So 96 plus 12 is 108, x plus 108. Now it's just algebra. Combine like terms, 5x plus 8. I get, when I subtract the 8, I get 100 is equal to 4x. So x ends up being 25. Now I can find the numerical value for this and the numerical value for that. 2x is 2 times 25 is 50, so this is 59 degrees, and this is 74 degrees. So finally, because the sum of the angles in a triangle add to 180, C plus 59 plus 74 is equal to 180. Subtract those values from 180, and you end up with, let's see here, 47 degrees. So this single problem incorporates quite a bit of pretty much everything in this little lesson. We have isosceles triangles, so base angles are congruent. We have the sum of the angles in a triangle to get the 96. Combine the 96 with the x plus 12 as an exterior angle, so we use the exterior angle theorem to come up with a value of x, and then we use the sum of the angles in a triangle again to get a value for C. And we will be working more problems in class, probably not quite to this level though. That kind of incorporates quite a bit, and it's a little bit more difficult to do on your own, but eventually you will get there.